If dy by dx plus 5y is equal to 1,000 and y at 0 is 100, find this function y in terms of x. So we notice, hey, we've got a linear, first order, linear differential equation. And it's already written in standard form, basically. I prefer to have a y prime, personally, but dy by dx, that's fine. It's got the plus a function too. Remember, the plus is so important for our process. Okay? So let's solve this linear differential equation. Y prime plus 5y equals 1,000. So we'll get the general solution, and then we will use this given information, y at 0 equals 100, to find the specific solution we want. Okay, so first things first, we need an integrating factor. Okay. So that's e to the antiderivative of your p of x function. Remember, the general form of a, just in case we've forgotten, y prime plus p of x y equals q of x. That is standard form for a first order linear differential equation. The plus is so important. That's why I always try and mention it. So in this case, our p of x is just a nice constant function 5. Well, that's going to be really easy to work with. Can I think of an antiderivative of 5? Sure I can. 5x. It doesn't have to be 5x. You can do 5x plus 1 or 5x minus pi. But I find if you just need an antiderivative, the one without the constant is always nice. Or the one where the constant is equal to 0 is fine. Okay, so now we multiply both sides of our differential equation by this integrating factor. Okay. And the reason we do this is because this whole left-hand side is exactly what you would get if you differentiate using the product rule your integrating factor times this unknown function y that we're trying to solve. Okay. That's the whole reason for introducing the integrating factor, is so that happens, and then everything else just sort of comes along for the ride. Now we want to figure out what y is. So what happens to y? First we multiply y by e to the 5x, so multiply it by a function, and then we take the derivative. Right? And then we know what that equals. So using sort of our principles of algebra, to isolate for y, we should take each of those operations and undo them in the reverse order. So how do you undo differentiation? You integrate. So if we integrate both sides, that should leave us with our integrating factor e to the 5x times y. And that should be equal to, well, integrate on one side, you got to integrate on the other side. Okay. So we get e to the 5xy, and then the 1,000 can come out. E to the 5x, what's an antiderivative of e to the 5x? E to the 5x over 5. And we can actually simplify a little bit. 1,000 divided by 5, that's just going to be 200. And then we're done our integration, so we add in the plus c. As soon as we are done, you don't want to get in the habit of just doing all your math and then at the end saying, oh, I integrated something, I need a plus c at the very end. Right? Let me show you what I mean by that. So let's say I'm lazy, or I just say, oh, who cares about plus c's? You always just tack them on at the end of a math problem anyway. If we then tried to isolate for y, what would we do? We'd divide both sides by e to the 5x, and you'd get y is 200 e to the 5x over e to the 5x. And they'd cancel out just fine, and you'd be left with y is 200. And then you'd say, oh, right, I'm supposed to add in a plus c. Well, it's going to be meaningless now. It's not going to be where it needs to be. Right? So as soon as you are done integrating, you have to add in the plus c. Notice how different it's going to get. So now we're going to divide both sides by e to the 5x. Okay? E to the 5x divided by e to the 5x is going to leave you with 200, but don't forget you also have c divided by e to the 5x, which I might rewrite as c e to the minus 5x. So there's our y of x as a general function for a specific value of c. There will be one specific value of c that also gives me a function that satisfies this condition, y at 0 is equal to 100. So let's find that c and get our final answer. So we get 200 plus some unknown c, e to the minus 50. Well, that's 200 plus c e to the 0. That's 200 plus c. Okay, 200 plus what is equal to 100? Negative 100. So c is negative 100, and that means our final answer is y is equal to 200 minus 100e to the minus 5x.